The derivative of a function is one of the basic concepts of mathematics. Together with the integral, derivative occupies a central place in calculus. The process of finding the derivative is called differentiation. The inverse operation for differentiation is called integration. The derivative of a function at some point characterizes the rate of change of the function at this point. We can estimate the rate of change by calculating the ratio of the change of the function delta y to the change of the independent variable delta x. In the definition of derivative, this ratio is considered in the limit as delta x approaches to 0. Let f of x be a function whose domain contains an open interval about some point x sub 0. Then the function f of x is said to be differentiable at x sub 0, and the derivative of f of x at x sub 0 is given by. So we have here the change of delta x and delta y, or delta y over delta x is the change of rate equivalent to slope. F prime of x sub 0 is equal to the limit where delta x approaches to 0 of delta y over delta x. The formula is equal to the limit wherein delta x approaches to 0 with a function of f sub x sub 0 plus delta x minus function of x sub 0 all over delta x. So this is the formula of the derivative based on limit. And for Lagrange notation, the derivative of the function of y is equal to function of x is equal to f prime of x or y prime. Leibniz notation is the derivative of the function of y is equal to f of x is equal to dy over dx. And here's the steps to find the derivative of a function f sub x at the point x sub 0 are as follows. First, you need to form the difference quotient, which is delta y over delta x, and it is equal to the function of the change of x, which is x sub 0 plus delta x minus the function of x sub 0 all over delta x. Once you have the equation, simplify the quotient in order for you to cancel the delta x if possible. And then find the derivative of f sub prime of x sub 0 and applying the limit to the quotient. If these limits exist, then we say that the function of f of x is differentiable at x sub 0. Example number 1. Find the derivative of the function f of x is equal to 3x plus 2 using the definition of derivative, which is the function prime of x is equal to the limit wherein delta x approaches to 0 with the function of x plus delta x minus the function of x all over delta x. We change to the function of x, which is 3x plus 2, or the limit of delta x approaches to 0 and function of x plus delta x, or 3 times x plus delta x plus 2 minus the function of x, which is open parenthesis 3x plus 2, and then we divide by delta x. Simplify. So the limit of the function delta x approaches to 0 is 3x plus 3 delta x plus 2 minus 3x minus times plus 2 minus 2, and then we divide by delta x. Check the similar terms, so you cancel out positive 2 and minus 2, 3x and negative 3, and the remaining is the limit at delta x approaches to 0 wherein 3 delta x all over delta x, and delta x over delta x cancel out, which means the limit of delta x approaches to 0 is equal to 3. Or if we change delta x to 0, we don't have value of delta x, so therefore the derivative of the function is equal to 3. So f prime of x is equal to 3. So that's example number 1. Another example, function of x is equal to x squared plus 2x minus 2, and find the derivative of function using the definition of the derivative. So the same formula. So f prime x is equal to the limit delta x approaches to 0 with a function of x plus delta x minus function of x and divide by delta x. Change the function of x plus delta x to the limit of delta x approaches to 0, and x squared means x plus delta x squared plus constant 2, and x instead of x, it should be x plus delta x, or x plus delta x minus 2 minus open parenthesis of the function of x, which is x squared plus 2x minus 2. So 2x squared plus 2x minus 2, and then we divide with delta x. Simplify. So the limit of delta x approaches to 0. This is expand x squared plus twice of x delta x plus delta x squared plus twice of x plus 2 times delta x, or plus 2 delta x minus 2. Change all the sign. So negative x squared, negative 2x, and negative times negative 2, positive 2. We divide by delta x. Simplify. The limit of delta x approaches to 0, and check for the similar terms to cancel out. So x squared minus x squared, so cancel out. Negative 2 and positive 2 cancel out. 2x and negative 2x cancel out. And the remaining values are 2x delta x plus delta x squared plus 2 delta x all over delta x. So we arrange delta x squared plus 2x delta x plus 2 delta x. We divide by delta x. The limit of delta x approaches 0. Extract all similar terms, which is delta x and delta x plus 2x plus 2, and we divide by delta x, and delta x cancel out. The remaining, it is the limit of delta x approaches to 0, delta x plus 2x plus 2. If we change delta x to 0, therefore the limit or the derivative of the function is equivalent to 2x plus 2. So this is the final answer for example number 2. Example number 3. F of x is equal to 1 over x minus 1. So this is a fraction. By formula, f prime of x is equal to the limit of delta x approaches to 0 and the function of x plus delta x, close parenthesis, minus f of x, and divide by delta x. The limit of delta x approaches to 0, function of x plus delta x, or 1 over x plus delta x minus 1 and minus function of x, which is 1 over x minus 1, and then we divide by delta x. We get the LCD. So we have the limit of delta x approaches to 0, and the least common denominator for the numerator is x plus delta x minus 1 and x minus 1, and x minus 1 minus 1 times x plus delta x minus 1, and divide again by delta x, and simplify. The limit of delta x approaches to 0, so this is x minus 1, change all the sign, negative x minus delta x plus 1, divide by the LCD of x plus delta x minus 1 and x minus 1. Cancel out x, negative 1, and positive 1, all over delta x. Limit of delta x approaches to 0, so the remaining value is negative delta x, and then we bring down all the denominator to another denominator, which is delta x and x plus delta x minus 1 and x minus 1. Cancel out delta x and delta x. So the limit of delta x approaches to 0 is equals to negative of all the denominator, which is x plus delta x minus 1, close parenthesis, and x minus 1. And that's the time we change the value of delta x to 0. We change it to negative 1 all over x plus 0 minus 1 and x minus 1. Negative 1 over x minus 1, same, therefore it is squared. So the derivative of the function of 1 over x minus 1 is equal to negative of 1 over x minus 1 squared. So this is the derivative of the function. Example number 4. Function of x is equal to 2 over x squared. Function of x prime is equal to the limit of delta x approaches to 0, and with the same formula we change x to x plus delta x, so 2 all over x plus delta x squared minus with the function of x, which is 2x squared, and we divide by delta x. Simplify. So limit of delta x approaches to 0, and the least common denominator, which is x plus delta x squared times x squared times 2, or 2x squared minus 2 times simplification of x plus delta x squared, or x squared plus 2x delta x plus delta x squared, close parenthesis, and this is the, and divide by delta x. Simplify. So limit of delta x approaches to 0, this is 2x squared minus, change the sign, so negative 2 x squared minus 2 times 2 is 4 x delta x minus 2 times plus delta x squared, or minus 2 delta x squared. Then the LCD, x plus delta x squared x squared, and then divide by delta x. The limit of delta x approaches to 0. Then check if we can cancel out. If yes, 2x squared minus 2x squared. So you cancel out 2x squared, negative 2x squared. The remaining, for the numerator, it's negative 4x delta x minus 2 delta x squared, and the denominator, which is simplified, so x squared plus twice of x delta x plus delta x squared times x squared, and divide by delta x. Again, so limit of delta x approaches to 0, extract delta x. So delta x, the remaining is negative 4x minus 2 delta x, and divide everything. So delta x and the LCD, copy x squared plus 2x delta x plus delta x squared and x squared. Cancel out delta x, negative 4x minus 2 delta x, divide by x squared plus 2x delta x plus delta x squared, and multiplied by x squared. The limit of x delta x captures is to 0, and we changed delta x to 0, which means negative 4x minus 0, and divide by x squared plus 2x times 0 plus 0 squared, and multiplied by x squared. And the denominator, we have x squared times x squared and negative 4x. And we cancel out negative, or cancel out x and x, so this one is cancelled out. The remaining is negative 4 all over x times x squared is x cubed, or the derivative of the function is equal to negative 4 over x cubed. Example number 5. Function of x is equal to x cubed, and we have the derivative of the cube. We have the derivative of cubic section, and then we change x to x plus delta x. So the function, or the f prime of x, is equal to the limit of delta x approaches to 0, and we change x to x plus delta x using the definition of derivative, or x plus delta x cubed minus the function of x, which is x cubed, and we divide by delta x. How can we expand x plus delta x cubed minus x cubed? So based on the difference of two cubes, the formula for that, it is a cube minus b cube is equal to a minus b, and multiplied by a squared plus ab plus b squared. In this case, our a is x plus delta x. So a is equals to x plus delta x, while b is equal to x. And then we substitute this to this formula, and the limit of delta x approaches to 0 with the delta x, a, which is x plus delta x. So x plus delta x minus b, which is x, open close parenthesis, a squared, which is x plus delta x squared, plus a plus a, which is x plus delta x, and b times x, plus b squared or x squared, and close parenthesis. Simplify. So the limit of delta x approaches to 0 and simplify. So this is delta x. X plus delta x minus x, close parenthesis, and simplify. X squared plus 2x delta x plus delta x squared, and plus x times x, x squared plus x delta x plus delta x squared, close parenthesis. So we cancel out x minus delta x, or x minus x. So cancel out, and the limit of delta x approaches to 0, which is delta x, open parenthesis. So we have x squared, x squared, x squared. So we have 1, 2, 3, or 3x squared. Then 2x delta x delta x, or plus 3x delta x. What about delta x squared? So remains, so plus delta x squared. And we divide, or close parenthesis, and we divide by delta x. And we cancel out delta x, and we change delta x to 0. So 3x squared plus 3x times 0 plus 0 squared, or 3x squared. So the derivative of the function of x cubed, and the value is 3x squared.